An icy wind blows over the permafrost on the desolate Kola Peninsula. This is an unforgiving landscape, barren and isolated, but it is where the Soviet Union hoped to make history. Inside a small concrete overstructure with corrugated iron panels rattling in the wind, a huge drill bit more than 20 centimeters in diameter is lowered towards the ground and begins to descend. The year is 1970, and the Cold War race for technological supremacy between the US and Soviet superpowers is, according to some, over. The Americans beat the Reds to the moon the previous summer, and space is now adorned with stars and stripes. The Russian cosmonauts are forever runners-up. But there is another lesser-known Cold War contest that the Soviets can still win, one not focused up towards the stars, but down into the Earth, to drill to the bottom of the Earth's crust, reach the mantle. The Russians' prospects are good since the US abandoned their attempt 4 years earlier. Just as with the race to the moon, the motivation for digging to the bottom of the crust was ostensibly a scientific one. Although we have rocks that have been uplifted, altered, and fractured from the top of the mantle, we don't have any fresh samples from this huge shell of scorching flowing rock. Geologists don't know for sure its composition, temperature, or dynamics. For that reason, the Americans began an ambitious project in 1958 to drill deeper than ever before to reach the Mohorovičić discontinuity known as the Moho, which is the boundary between the mantle and the crust. For this so-called Project Moho, they chose to drill into the seafloor where the oceanic crust is thinner. Unfortunately, that meant drilling from a floating platform on the open ocean, something that is common now but had never been done before. The development costs soared, and the project was abandoned in 1966. It was possible for the Russians to take things slowly and steadily, making their way through the granite layers until they could see their objective. The Kola Superdeep Borehole is barely 20 centimeters broad, but it extends over a significant distance of 12 kilometers. The most profound man-made crater on the entire world. In addition, these extremely deep rocks provide researchers with an incredible insight into the time frame of the early Earth. In addition, these rocks have been bent, faulted, and crushed, and they have undergone metamorphosis into new forms. They are around 2 billion years old. However, it is still possible to recreate them in order to get a view of the surroundings in which they were formed. There are even organic microfossils as well as the relics of volcano sediments from rivers and oceans and other places. The picture that emerges is one that is surprisingly typical of Earth. It is almost unmistakable. However, in other parts of the world, rocks that date back only 100 million years tell a totally different picture. These rocks tell of a chemical and climatic catastrophe that brought the whole planet that could support life to its knees. The question that arises from this is how the Earth went from being a barren rock to the beginnings of the world that we know today. And was the Earth truly as perfect as it appears to have been 2 billion years ago? As the rocks appear to show, this film is sponsored by Magellan TV, which is a streaming service that specializes in documentaries. The early Proterozoic Earth appeared to be lifeless when viewed from a distance. Even though it is just 2 billion years old, the Earth is only a little more than half of its current age. It is only a little further away from the moment it was formed than it is from the present day. Beginning with the molten heat of its formation and ending with the gripping cold of a global ice age, it has experienced a wide range of temperatures throughout its history. This wet ball of rock was the location where the most improbable event took place. Life progressed over time. That life was able to learn how to flourish in all of the settings that the Earth has to offer, developed new methods of obtaining energy, and came dangerously close to extinction in the process, first through a chemical catastrophe and then through a climate catastrophe. The release of oxygen into the atmosphere by photosynthesis had been the cause of the global Huronian glaciation. This release of oxygen had stripped the air of its most powerful greenhouse gas, methane, while the photosynthetic bacteria continued to consume carbon dioxide, further reducing the amount of insulating blanket that the planet had. After being subjected to the faint rays of a sun that was still young, the planet cooled all the way down to its equator. At one time, the oceans had a brilliant blue and green color, but now they were covered by calm and steady sea ice. In addition, ice coated the country as the final clouds deposited their icy burdens over the highest summits of the surrounding mountains. When the surface of the world was confined within this prison of ice confinement that seemed to last forever, what was the next step? Approximately 2 years after the Soviet Union began digging in the Arctic, French engineers uncovered a riddle that had been around for 2 billion years in rocks that were located near to the equator. For the purpose of shedding light on a Proterozoic world emerging from cryostasis, the solution to that puzzle would be helpful. The Pierre Latte nuclear processing plant was a facility that was dedicated to enriching uranium from its mined ores for use in power plants and nuclear weapons. It was located on the banks of the Rhone in the southeast region of France. Because of the intensification of the Cold War, scientists had a very good understanding of the characteristics of uranium and the ores that contain it by the year 1972. They were aware, for instance, that every natural supply of uranium on Earth, including meteorites, and the Moon included 3 uranium isotopes, which are variants of the same element with slightly different masses, and that these isotopes were always in the same ratio. The most radioactive element, uranium-235, has consistently accounted for 0.72% of the total. Consequently, the French engineers were perplexed when they found out that a batch of uranium that had been extracted from their mines in Gabon contained less than this, specifically 0.6%. It is possible that the difference is not significant, yet it was unheard of anyplace else on or off the globe. As much as 200 kilos of uranium, which is sufficient to produce 12 nuclear weapons, appeared to have been stolen from a single source. An investigation of this concerning disparity was carried out by geologists who were dispatched to the Okhlat mine in Gabon. They discovered no instances of misbehavior or theft of uranium. Instead, they discovered a fascinating natural phenomenon, a natural nuclear reactor that was buried deep below the Proterozoic rocks and had been smoldering away for hundreds of thousands of years. In the event that stars undergo catastrophic explosions known as supernovae, the heavy element uranium is produced under distinct circumstances. When the Earth was first forming around the newly ignited sun, it was able to seize uranium that was floating freely from the whirling disk of dust and gas that was around the young star. Because of this, our globe is brimming with it, both on the inside and the outside. Uranium, on the other hand, is of the utmost importance to us humans when it is concentrated even more, which enables us to readily harvest its ores for use in our energy-hungry warring civilizations. The massive cycling of rocks and water through the surface layers of the Earth is one of the most effective ways for uranium to be brought together and concentrated. This is one of the best techniques. There is a possibility that the element will dissolve in water and then be transferred together with river sediments or through hydrothermal plumbing systems that are located around volcanoes. The uranium had been brought together at the Okhlat mine in Gabon by the process of mineralizing volcanic fluids that flowed through sedimentary rocks that were extremely old and rich in organic carbon. In addition, some 2 billion years ago, tectonic pressures started to bring these rocks together, with the uranium ore veins that were embedded inside them closer to the surface. In this specific location, it seemed as though the natural processes that were taking place were sufficient to concentrate the uranium-235 to levels that were significantly higher than what is typically encountered. Groundwater would seep through the rocks and around the uranium as they were brought closer to the surface of the Earth. Because of the presence of water, the neutron products of radioactive decay are slowed down, which helps to retain them close together and contributes to the initiation of a chain reaction within the densely concentrated uranium deposit. Because of this, a nuclear reaction that is self-sustaining might proceed in a natural way. For a period of time, The heat that is being released by the continuous decay would finally be sufficient to boil the water that is acting as a mediator. This would result in the formation of tremendous plumes of radioactive steam that would emerge from the surface of the Earth like deadly geysers. When these geysers with yellow rings erupt, the reaction that is taking on underneath comes to a complete end. In the absence of water to sustain the fission process, the products of decay are able to escape without any harm. Consequently, this proceeded in pulses of fission that lasted for a period of 30 minutes. After hundreds of millennia, this faithful cycle continued until the uranium at Ocelot, which had been so abundant in the past, was reduced to levels that were below natural levels. As a result, the natural reactor went into complete silence. It was a revolutionary finding when a nuclear reactor that was 2 billion years old was found in the rocks of Gabon. This discovery confirmed theories that had been made decades before. However, in addition to providing us with a glimpse into a peculiar and dynamic world that existed 2,000 million years ago, they also provide us with a great deal of information regarding activities that were typical on Earth during this time period. There were ecosystems that were stable and sedimentary, such as rivers, deltas, and shallow ocean basins. These environments were places where living organisms lived and died in large numbers, which resulted in the sediments being enriched with organic carbon. The hydrothermal and volcanic plumbing systems that are present in these sediments and the rocks that they produce are responsible for the concentration of rare minerals and the modification of the chemistry of the rocks that they penetrate. Moreover, as these rocks are being created, they are constantly being distorted by tectonic forces which either push them deeper into the crust or elevate them to the surface where they are vulnerable to the damaging effects of water, air, and biological activities. All of it might seem familiar to you. They are in fact the processes that are responsible for shaping the surface of our planet at the present time. On the other hand, they come as a shock because they emerged so soon after the terrible Huronian Big Freeze. Gabon reveals that the Earth did indeed arise 2 billion years ago, despite the fact that it does not explain how this occurred. Throughout the course of hundreds of millions of years, it has been covered by ice from the pole to the equator. It has been difficult for life to get where it could. On the other hand, with the help of forces that are buried deep under the Earth, the tide is now beginning to shift quite literally. During the time that the Huronian glacial is in control, there are just a few locations where any kind of activity may be observed. The center of the planet is still quite heated, despite the fact that the surface of the ice is completely covered with silence. Volcanoes pierce through the shell, releasing orange lava that eventually turns into black rock and spews gray ash over the surface that is completely white. The water bodies that are located in close proximity to these volcanic pustules are sufficiently warm to prevent the ice from advancing and to serve as a safe haven for the 1% of life that managed to survive through the unending winter seasons. Massive and slow tectonic forces are progressively altering the crust, and the volcanoes that punch through the top are the outward expression of these forces. As a result of horizontal convection inside the turbulent mantle, enormous rafts of rock collide with one another and grind against one another. As one slab slides beneath another, gravity exerts a pulling force on the suspended slab, which in turn pulls the remaining raft in a sideways direction behind it. When it comes to plate tectonics, these so-called subducting borders are the most important. Plate tectonics is responsible for the reconfiguration of the initial continental masses over the course of hundreds of millions of years. This process is taking place beneath the ice that covers the Huronian glacial. The rocks that have survived from this time period, such as those from Gabon and the Kola Peninsula, amongst others, retain the telltale marks of this continental dance. This is despite the fact that scientists are incapable of pinpointing the exact moment when real plate tectonics was created. Before they became solid, the earliest volcanoes on Earth would have been black shields that were shallow in depth, similar to the shields that are found in Hawaii and Iceland today. These shields would have been generated by lava that flowed freely following the slightest gradient and flooding a great distance away from the source. When tectonic plates collide, they cause a tectonic sumo to occur, which causes the crust to get crumpled and thickened. This in turn causes mountain ranges to be lifted and roots to be forced down, which then propel them tens of kilometers deeper into the ground. The water that is released from the fatal slab melts the mantle that surrounds it at the subducting borders, which results in the formation of magma that flows upwards and into the roots of the mountain. This lava is unable to exit so quickly, and it has been buried at the center of the mountain for hundreds of thousands of years. The dark-colored and heavy minerals that it contains crystallize and sink to the bottom, leaving behind a new type of lava that is lighter in color, more sticky, and laced with gas. When this magma eventually makes its way to the surface, it gives rise to a volcano that is quite distinct from the common type. It doesn't take the lava very long to reach its destination before it cools down and stops, resulting in the formation of enormous conical piles. In addition, the pressure that is being exerted by the magma and gas continues to increase until the volcanic pile is blown apart by some deadly explosions. The roar of these eruptions can be heard across approximately half of the world. They elevate ash and toxic vapors to enormous heights in the sky, where they are carried by rapid jet streams for great distances. Using this method, these stratovolcanoes construct tall cones and then blow themselves apart on a regular basis. Despite the fact that we are aware of the existence of these thickening volcanic ranges, the fragmented geological remains from this time period make it difficult to determine the precise arrangement of the beginning of the continents. The volcanic and metamorphic rocks that date back 2 billion years are examined in great detail by geologists in order to reconstruct the collisions that must have occurred in order to form these rocks, as well as the continental fragments that were engaged in those collisions. Furthermore, there is an increasing body of evidence suggesting that practically all of the landmasses that make up the continents were crushed together to form one enormous supercontinent that is known as Colombia. It is believed by researchers that Colombia extended around 13,000 kilometers from north to south. From Portugal to the Bering Strait, it is larger than the region that is now known as Eurasia. On the other hand, this remarkable supercontinent was still buried in ice for a significant portion of early Proterozoic history. The blinding white color of glaciers, ice caps, and ice shelves serves no purpose other than to reflect the heat of the sun back into space, so extending the period of cooler temperatures by millions of years longer than any typical ice age. The idea that the Earth will ever be able to break free from its current state is difficult to believe. This hot interior, however, is going to be the savior of Earth. Water vapor and carbon dioxide are being blasted back into the atmosphere with each new explosive volcano and each new continental collision that occurs. As time passes, the atmosphere gradually regains its capacity to retain the heat from the sun. And the heat from that sun continues to increase, although little with each passing year. The brightness of our home star increases by 6% per billion years as it matures and becomes more luminous as it ages. An increase in the temperature of the sun and improvements in insolation have made it possible for the Earth to emerge from its deep freeze after it has been frozen for 300 million years. For the same reason that the white ice had reflected the warmth of the sun, the newly exposed dark waters and land surfaces have absorbed it, which has accelerated the retreat of the ice. It is possible that the rebirth of Earth took place in a span of only a few hundred years. However, all of the water that was previously contained within the ice must be transported to a different location. The oceans are, of course, the location in question. A global sea level rise of enormous proportions is caused by the introduction of large amounts of fresh water into the oceans during the Proterozoic period. In the process of newly formed land surfaces being reclaimed by the sea, coastlines are being submerged, and the Colombian supercontinent is shrinking from its edges. In addition, in every region of the Earth, rocks that date back 2 billion years maintain the record of this catastrophe. we are able to rebuild huge continental shelves that contain massive river deltas, which geologists refer to as a marine transgression. Sedimentary rocks eventually intrude over older land surfaces that have been weathered. The formation of protected bays and lagoons occurs at the points when water breaches mountainous environments. There are shallow waterways that are packed with fine sediments that are rich in nutrients. These sediments are the result of new erosional chemistry occurring on virgin rock surfaces. These sediments are found along the margins of the continent. As the waves gently lap on the fractal coastline, the lagoons start to take on a tropical blue color. The planet enjoys the warmth of the sun. While the Great Flood that occurred 2 billion years ago was unquestionably a momentous occurrence, it was not a catastrophic one by any stretch of the imagination. In the case of a living biosphere that was confined to the oceans, the shoreline's drowning was something that should be embraced rather than dreaded. The violations that occurred in the ocean served to create a real Eden for the photosynthetic life forms that yearned for both the water and the light during their existence. Furthermore, in this newly discovered utopia, they did not waste any time in spreading, multiplying, and even experimenting with new things. Iron-rich rocks were discovered along the southern shores of Lake Superior in North America in the 19th century, which led to the development of a robust iron and steel industry throughout the region. It is possible that these rocks alone are responsible for the development of the automobile industry in Detroit, which ultimately led to the transformation of the face of the United States of America. Therefore, it should not come as much of a surprise that these Proto-Erozoic deposits have been the focus of a significant amount of research over the past 150 years. Geologists have high hopes of unlocking the Proto-Erozoic rock record and uncovering additional ancient treasures if they can gain a better knowledge of how these rocks originated, when they formed, and the conditions under which they developed. As a matter of fact, this is precisely what Stanley Tyler, a professor of geology at the University of Wisconsin, discovered in the early 1950s. Tyler and his crew had dug a test pit that was 20 feet deep into the iron-bearing rocks of Iron River, Michigan, and they had taken samples from the strata that were the deepest. In the sunlight, the sample that Tyler was holding in his hand was a pitch-black color that sparkled. It was something he had seen before, but he had never anticipated finding it in rocks that were so old. To the trained eye of his educated eye, it appeared to be coal. However, before they could continue their research, a catastrophe occurred and the walls of the pit collapsed, burying this strange sample source behind tons of rock that was jumbled together. Also, Barghorn, a paleobotanist at Harvard University, was the person that Tyler sought out for a second opinion on this valuable and uncommon sample of Proto-Erozoic coal. Tyler resorted to her since she was another specialist in the subject. Both of these gentlemen were aware of the fact that the oldest known examples of coal on Earth were years and years older. When compared to the majority of coal, which is only 350 million years old and dates back to the time when trees were growing during the Carboniferous period, these rocks were nearly 2 billion years old. On the other hand, when Barghorn analyzed the samples that Tyler had provided, he validated the geologist's findings. He came to the conclusion that this sample must have originated from biological sources because it contained about 80% pure organic carbon. It was algae, not trees, that were the source of such prodigious productivity, according to the fine-scale structures that were found within this ancient coal. The shallow Proto-Erozoic seas were home to colonies of photosynthesizing bacteria that proliferated in such large numbers that they left behind layers of coal that were comparable to those left behind by the Great Age of Trees, which occurred 1.5 billion years later. After a few years had passed, Tyler and Barghorn went on an expedition together following the shore of Lake Superior all the way north into Canada in an effort to find additional evidence of this ancient green algae forest. While they were on their journey, they traveled by boat and hopped between shoreline outcrops. The soothing waves of the lake prevented a marching spruce and pine forest from approaching. Here in the Gunflint Range of Ontario, they found dome-shaped layered formations that had been cross-cut by the waves, producing concentric rings in the smooth rock that dipped downward to the water's edge. These structures had been identified by the researchers. These were stromatolites, which were towering microcosms that were constructed layer by photosynthetic bacteria that lived in the sun. In other places, the two individuals found strata of chert, which is a glassy silicate rock that is also referred to as flint. The Gunflint Range is named after this type of rock. For the purpose of conducting more in-depth research after they returned to dry land, the professors gathered as much of this chart as they could because it was just as dark as the coal that Tyler had discovered many years earlier. In order to ensure that light could easily flow through the silicate crystals, they meticulously sliced and ground portions of the dark chert that were as thin as one sheet of paper. It was eventually possible to determine the reason for the dark color when viewed via a microscope. The number and variety of microfossils that were housed within these cherts was truly astounding. These extraordinarily minute carbon structures had a diameter of only a few 10,000ths of a millimeter, but they were intricate and unquestionably biological in nature. It was with this discovery that Stanley Tyler and Elsa Barghorn made history in 1953 by being the first people to find fossils that preceded the age of mammals. The bacteria found in Gunflint were the oldest fossils discovered during that time period by approximately 1.5 billion years. The microscopic world that Stanley Tyler unveiled was magnificent. He had gone out to discover miracles in the iron formations of Michigan and Ontario, and he succeeded in doing so, further than anything he could have ever conceived of. The fact that the Proterozoic Gunflint cherts contained a large number of different types of microbial fossils demonstrated that life had not spent any time in recovering from the great oxygen extinction. At the time of 2 billion years ago, the shallow oceans were once again teeming with life, and the new generations were able to withstand the previously poisonous gas that now filled the atmosphere. In spite of this, the oxygen levels in the Proterozoic period were not even near the concentrations that exist today, yet there was sufficient oxygen for new transformations to start at the top of the atmosphere. Ozone is formed when molecules of oxygen are broken apart and then recombined into ozone by ultraviolet radiation from the sun. This process results in the formation of an invisible layer in the stratosphere that absorbs ultraviolet light before it reaches the surface. It is now possible for photosynthetic life to survive closer to the surface of the ocean than it ever has previously, since this harmful radiation is no longer pouring over the land and ocean surfaces. Even moving to populate the enormous tidal flats that have been produced as a result of the rising sea level around the world. A playground for algae, the newly formed shallow lagoons that surround the Colombian supercontinent are surrounded by protective ozone, and their turquoise color quickly transforms into green with the blooming of verdant plants. This newly discovered Eden is the place where life can finally be free to do more than just survive there. It flourishes by consuming the bounty that the earth and the sun provide, and it develops new strategies to obtain an advantage over their bacterial counterparts. At this time, there is a greater emphasis placed on the pursuit of new cooperative interactions between various species of bacteria. In the process of incomplete predation, the prey is imprisoned within the bodies of their masters. This allows the two of them to create a new branch on the tree of life, which is the first eukaryotic organisms. The existence of eukaryotic cells from 2 billion years ago is not supported by any direct fossil evidence, and the precise time at which this significant change had happened is unknown to the scientific community. However, there are a few peculiar fossils that have been discovered in Gabon that may indicate that in other parts of the world, more complicated cells allowed for the exploration of whole new ways of existence. One of these fossils could be easily disregarded as ordinary gouges in the surface of a smooth gray mudstone. Nevertheless, a closer inspection of these gouges reveals that they are connected beneath the surface, producing tubular tunnels and tracks that look like some kind of tortured ancient subway system. Despite the fact that there is no proof of the organisms that were responsible for their creation, the organic carbon that was left behind appears to indicate their biological origin. Our first indication of organisms moving on their own, these footprints in the sand, date back to 2.1 billion years ago, making them the oldest footprints ever found in the sea. A slug-like colony of amoeba-like cells migrating together and tunneling through soft dirt and bacterial mats in quest of nutrition or safety is what scientists believe was responsible for their creation. An additional fossil taken from Gabon has been subjected to a more critical analysis, not the least of which is due to the fact that it reveals an even more extreme biological experiment. This peculiarly flattened shape, which measures 12 centimeters wide, is something that looks like a cooked egg with scalloped edges. According to the people who made the discovery, these fossilized remains are the relics of multicellular animals that existed 400 million years before multicellularity became widespread. Some people are more skeptical, speculating that the structures might have been generated by purely physical processes, and that they just happen to mimic structures that are found in the natural world. In the event that they actually represent an experiment in life expanding to encompass a larger size, then that experiment was a failure. It is not possible to find these Proterozoic fried eggs anyplace else in the planet or in any additional layers of rock that are younger. It is, however, abundantly obvious that the Earth is now the property of its life forms. Life was no longer held back, not by chemical limitations nor physical barriers. As microscopic organisms lived, died, and trapped carbon within their remains, they left behind black layers on the ocean floor. Over time, these dark stains turned the shallow supercontinental shelf into a cradle of green, a thriving ecosystem built on the bones of the past. Meanwhile, far to the north in the icy wilderness of the Russian Arctic, the Soviet Union was drilling into time itself. Their Superdeep Borehole on the Kola Peninsula pierced through ancient Proterozoic rocks, unearthing a hidden archive of Earth's history sediment, rich in ancient life, pale volcanic stone, and frozen magma that once pulsed beneath a primordial supercontinent. In a feat of determination, Soviet engineers spent 2 decades drilling deeper and deeper. And while they never reached the mantle or even the elusive Moho boundary, they achieved something no one else ever had. At 1225 kilometers down, they hit the bottom. The borehole was sealed with a cap of iron, but the legacy it left behind remains unmatched. To this day, it is the deepest hole humanity has ever carved into the Earth. Ironically, we know more about the moon's surface than the ground beneath our own feet. But the Kola borehole gave us something profound, not just data, but a doorway through time. In the heart of a frozen land, we glimpsed a prehistoric world rich with life struggle and transformation. The Earth has stories to tell far older than any civilization, deeper than any ocean. If you've been fascinated by this journey, imagine what else lies buried beneath our feet. Subscribe to our channel for more extraordinary stories from the hidden past of our planet. And if you want to explore the mysteries of time, space, and life itself, don't stop here. The next revelation could be just one video away.